when these villus will become cystic like a grape-like structures. So let's see exactly how the hydatidiform mole look like. This is the normal placenta. So have a look at this carefully. Now you see that. You can see the distinct difference. It is also a placenta, but we can see some cystic structure on the surface of the placenta, and this is basically a maternal surface. So this is not a normal finding. We can see the cystic appearance. We can see some of the big cysts, some of the cysts are really small, embedded into the placenta. And remember once again, when you see this cystic change, the cysts are nothing but a cystically dilated villus. And once we see this kind of situation, what is the name of the disease? Hydatidiform mole. I repeat again, hydatidiform mole. So have a good look at these things. This is what happens in some cases, and this hydatidiform mole can be classified into two basic groups: complete mole and the partial mole. So here again the complete and the partial mole, and we shall be discussing now the etiology of this hydatidiform mole. These mole are very common in the Asian countries, and mother who are over 40 years of age or under 20 years of age. This is the pathogenesis of the complete mole. So have a look at this picture very carefully. There are two scenarios explained here. If you look at the upper part of this scenario of the complete mole pathogenesis, you see an egg. Look at it very carefully. Egg means ova, but it has no DNA. So it is a ova which is devoid of all maternal DNA. Now this particular ova is now fertilized by two sperms. You know, each of these sperms are like a haploid. So these two sperm may be 2x or 1x 1y. So this is a fertilization is taking place. So once this fertilization is taking place, we are getting a material after this fertilization, and that particular fertilization will produce a cell which has got 46XX or 46XY number of chromosome. And not to forget that this is a fertilization between the two sperms. Very weird, isn't it? So this cell, which contains only two type of cells composed of the paternal chromosome, paternal, only from the father. Naturally, they cannot produce any baby because it has got only paternal chromosome, and this mole is known as androgenic mole. What is the scenario number 2? In the scenario number 2, it is just one sperm, and this one sperm can be X or Y. This will fertilize, so-called fertilize, it is a misnomer word, fertilize this empty egg which has got no DNA, and after that single sperm it will duplicate. Now it will duplicate to produce a 46X number of chromosome, and once again this cannot produce a baby, and all the chromosome present in this fertilized cell, they are androgenic cell. In a situation like that, what happens? We get a complete mole, which means all villi, all, I am using the word, suppose there are 2000 villi in a placenta, all 2000 villi will be cystically dilated. Never ever forget this, and in that case we call it a complete mole. You got it? So point is here, there is no maternal DNA. The ova does not contain a maternal DNA, but it is fertilized by two separate sperm or one single sperm. This is a partial mole. In the partial mole, the mother's egg or the egg is normal, which has got 23 haploid chromosome. Now what is happening here? This particular normal ova is fertilized by 2 sperm or sometimes is 1 sperm. In this case, if it is a 2 sperm, one of them is X, another one of them is Y, or both of them can be Y chromosome, or both of them can be X chromosome. So any kind of combination might take place. Or it could be 1 sperm which has a diploid number of chromosome. So this is abnormal sperm. So ultimately what is happening, you are getting a cell which has got at least triploid number of chromosome, and this is an important point. Triploid chromosome or anything more than that is basically a feature of the partial mole. But one thing is important to understand again, whatever may be the number of chromosome, it has to be more than 69. But this cell contains both maternal and the paternal chromosome. It means this particular cell will try, an attempt will be made, will try to make a baby. And in that particular case, it is a partial mole, and in that case, some villus would be normal in appearance. So this is a partial mole. Remember, complete and partial mole pathogenesis is a very important issue to understand. So is there any way that we can compare and contrast these two kind of moles? Let's see. Look at the picture again. What is your impression from this picture? Is it a complete mole or a partial mole? Use the definition. What is a complete mole? All villi should be cystically dilated, all of them. But do you think from this picture that all villi are really dilated, or it is some? Yes, it is some villi are dilated, not all of them. So in which group should it fall? It is basically the partial mole. And once we diagnose this one as a partial mole, then naturally the next question should come, what is the karyotype of this particular mole? Remember, it should be any number beyond 69. So 69XXY, 69XXX, 69XYY, so any kind of combination would take place. So remember, it is a classical example of a partial mole, and this is how it look like. So this is a kind of list. We have to just keep on repeating and remember the list. Why these villus are cystically dilated? Remember, it is a degenerative condition when we can see the extreme villus edema, and this edema produce these cystic changes of the villus. So complete mole, all villi are edematous. Partial mole, some villi are edematous, others are normal. Karyotype, complete mole 46XX or 46XY. In the partial mole, it has to be triploid, like 69XXY. It is one of the example here, but it could be other sex chromosome as well. Complete mole, we get extreme elevation of the serum beta HCG, which is extremely elevated. In the partial mole, it is less elevated. Now this is a urine beta HCG. So here also it is more elevated for the complete mole. Behavior, this is the most important thing. This is a very, very important thing. Complete mole, since it does not contain any maternal tissue, this mole has a chance to develop a choriocarcinoma. And what is the ratio or percentage of the choriocarcinoma? 2%. Here the 2% is a very important percentage or number that we must remember. Whereas in the partial mole, it is extremely rare to get a choriocarcinoma. So which one is better? Of course, it is a partial mole. So here